here we go. We have IAL Maths 2025 past paper. There are 10 questions. The mark is 75. Okay, so let's get started. Now, given that p is equal to 1 over 16 x to the power of 4 and q is equal to 40 divided by x to the power of 3, express each of the following in the form k x to the power of n, where k and n are fully simplified constant. Okay, here, okay, to the p to the power of half, we have to sub in this value of p over here. Yeah, all right. Let me select red pen. Yeah, so 1 over 16, okay, x to the power of 4, this is going to be whole to the power of half. Okay, all right, so because this is the p and it says the whole of p to the power of half. Okay, now what we need to do, okay, you have to split this up. Okay, and here now you have to find 1 over 16 to the power of half. Okay, so I mean okay, so this is going to do basically going to be 1 to the power of a half, 16 to the power of a half, okay, times by x to the power of 4 times to the power of half. Okay, here, okay, we have to multiply the powers. Okay, so 4 times a half is 2. Okay, 2 ones are 2, 2 twos are 4. Yeah, so x is going to be to the power of 2, and 1 over 16, yeah, to the power of a half, this is going to be 1 over 4, because 16 to the power of half is just square root. Yeah, and square root of 16 is going to be 1 over 4 x to the power of 2. Okay, that is going to be our final answer. Okay, let's move on to the B question over here. Okay, now it says that we have to express pq to the power of -1. Okay, so pq to the power of -1, where p is equal to, okay, 1 over 16 x to the power of 4. Okay, and 40 q is 40 x to the power of 3, x cubed. Yeah, all right, so this 1 pq, this pq to whole to the power of -1 can be written as this pq. Okay, because the laws of indices say that anything to the power of -1, you can write this 1 over n. Yeah, all right, and here what we need to do is we need to sub in these values of p and q. Okay, now this I will write as x to the power of 4 over 16, just similar. Okay, just there are different ways of writing, so I'm going to write in this way just for my convenience and easiness, times by, right, 40, okay, x to the power of 3. All right, this is going to give us 40 x to the power of 4 over 16 x to the power of 3 divided by 1. Okay, now you can divide the powers. Okay, 4 divide, I mean 4 minus the powers. Whenever the powers are divided, you have to minus the powers. Okay, right, So this is going to leave us with 1. Yeah, 4 minus 3 is 1. Yeah. All right, so 40 over 16 is going to be 5 over 2. Okay, if we simplify it, and this is going to give us x. Okay, this can be written as 5x over 2. Okay, and now we can do like this, keep, flip, change. Yeah, this can be written as 2 to the power of 5x. Okay, or you can write 2 over 5x, doesn't really matter. Yeah, all right. Yeah, now it asks for pq squared. Okay, I don't have any space over here, so yeah. All right, so p is for my convenience I'm going to write x to the power 4 over 16. Okay, times by q square, which is 40 over x to the power of 3 whole squared. Okay, uh now 40 to the, this can be written as this. Okay, 3 to the power of 2. Okay, so x to the power of 4 over 16, 40 cubed, okay, is 1600 over 3 times 2. Yeah, since this is whole power, we put a bracket, and whenever there's a power inside the bracket and outside bracket, we multiply them. Okay, so 3 times 2 is going to be 6. Okay, so this is going to be 1600 over to the power of 4, 16x to the power of 6. All right, so this can be simplified to give us 100. 4 minus 6 is going to give us x to the power of minus 2. All right. Yeah, so that's our final answer. Okay, now curve 2 has this equation, y is equal to 2x to the power of 5 over 2 minus 4x plus 3. Find dy by dx. Okay, this is relatively easy. Okay, so 2 times by 5 over 2, okay, is going to be 5. Differentiation works basically like this. For example, this is an expression. Okay, you just times an and then you do the power of minus 1. That's how we differentiate. Okay, so this is going to give us 5x. Okay, 2 times 5 over 2, and 5 over 2 minus 1 is going to give us 3 over 2. Okay, minus 4. Okay, x to the power of 1, so minus 4 times 1 is just 4. X is going to be basically 1 minus 1 is just 0, and anything to the power of 0 is 1, and this constant is going to differentiate to 0, because this constant is basically is this x to the power of 0, which is 1, and 3 times 1 is 3. Yeah, so whenever we do this differentiation, okay, 3 times by 0 is just 0, and 0 to the power of minus 1, but when anything you times by 0, it just 0. Okay, so that's why constants always differentiate to 0. Okay, all right. Okay, okay, so here's our dy over dx. Okay, just simple thing, this coefficient of x times by the power minus it by power minus it by 1 then. Okay, all right. Part B says the point P lies on C given that x coordinate of P is 2k where k is a constant. Okay, so and they have given the gradient at C at point P is 16. Okay, so if they have given the gradient of curve, that means that we need to find the x coordinate. Okay, so basically we know that dy by dx, which is the gradient of the curve, is 16. We don't know the x coordinate, yeah, right, and we need to find that. Okay, which can be written as 2 to the power of k, and then we have to find the value of k. Okay, so basically this is going to be, you have to substitute dy by dx is equal to 16 is equal to, okay, so this dy by dx equation, okay, 5x to the power of 3 over 2 minus 4. Okay, now 16 plus 4, if you add to 4 on both sides, this is going to give us 20. 5x to the power of 3 over 2 divide by 5 on both sides. Okay, 20 over 5 is going to give us 4 is equal to x to the power of 3 over 2. All right, so we need to get, okay, rid of this power to find a single value of x. So what we can do is times this by the opposite power. Okay, 2 over 3. So that means that if we multiply, this can cancel out, the power cancels out. Okay, we just have to the power of 1. Okay, so when you multiply, 3's cancel out, 2's cancel out. Okay, and on other side we have 4 to the power of 2 over 3. Okay, now basically this, so basically this is 4 to the power of 4 to the power of 3. Okay, so basically this is going to be let me think about it. Yeah, oh yeah, I forgot it. Yeah, we don't need to write 4 to the power of 3. Basically here 4 is a square number, so we can write this 4 is equal to 2 squared. Yeah, I thought we have to like write 4 to the power of 2 over 3. That's going to be rational number, I mean the rational number, the decimals. Yeah, so this is can written as 4 can be written as 2 to the power of 2 because it says that we have to express in 2k, and this can be, now you have to express 2 to the power of 2 inside the bracket. Okay, and now you have to use the laws of indices 2 times 2 times 2 over 3, since 2 over 3 and 2 to the power of 2 are inside the bracket and this one is outside the bracket. So 2 times 2 over 3 is going to give us 2 to the power of 4 over 3 is equal to x. Now this is in the form of 2k, and now k is going to be 4 over 3. Okay, all right, so here is our question number 2 done. All right, so here we have to find the integral of x plus 3 bracket square divided by 3 root x in respect to x dx. Okay, over here now we have to expand this power. Okay, because we can't directly find the integral because we need a expression in its simplest form. So that's how we can find the integral. Yeah, and also how to find the integral, basically for this is basically like integration without limits. Okay, so how we do integration, well, it is just going to be n, you add a power, divide by the new pure power, which is going to be n plus 1. Okay, all right. So first, we can't do that directly. First we have to do some expansion and simplification. Okay, so we can expand this bracket. Okay, so x plus 3 squared is just x plus 3 over 3 root x, okay, in respective to x. Now expand the brackets. Okay, x squared, okay, plus 3x plus 3x plus 9, okay, over 3 root plus 3x as well, okay, and respective to x. So x squared plus 3 is going to give us 6x plus 9 over 3. Now this root x can be any square root, can be expressed to the power of half. Okay, this is a indices rule you should know by now. Okay, x to the power of half. Now what we can do to write as a single expression, okay, with what we can do, that we can split it up. Okay, so we can do some splitting up over here. All right, and we can also write this. Okay, split it up. Okay, because this is now the common denominator of these numbers. Okay, all right, so we can write them as separate fractions. Okay, all right, so now we need to use the laws of indices. Okay, so we know that bases are same, and we can do 2 minus to the power of half. Whenever the powers are divided, you minus them. Okay, so this is going to give us 1 over 3 x. This is basically just 1. Okay, and 1 divided by 3 is just 1 over 3, and 2 to the power of 2 minus a half is going to give us 3 over 2, plus 6 over 3 is just going to give us 2, and 1 minus a half is just a half, plus 9 over 3. Well, 9 over 3 is going to be 3. Okay, now over here, whenever you take this expression, this power, this is going to be, okay, this is going to be minus a half. Why? Because I think so I mentioned this before. Okay, anything, okay, anything, if there's a like a what we say, what we call this, anything like a term to the power of n, this can be written as, we can take this a up, okay, and we can write this to the negative power. Okay, all right, this is a laws of indices that you need to apply over here. Now we can finally integrate it. Now we have, you know, in simplest form. Okay, all right, so now to integrate, we have to add to the plus 1, add a power of 1, divide by new power. Okay, plus 2x to the power of half plus 1 over 1/2 plus 1, plus 3x to the power minus a half plus 1 over minus a half plus 1 plus c. Okay, all right, the constant of integration should be there, otherwise you will lose marks. So 1 over 3 plus 3 over 2 plus 1 is going to give us 2 over 15 x. 3 over 2 plus 1 is 5 over 2, and now you have to, basically you need to divide this, okay, and this. Okay, divide this, okay, add this. Same over here. Divide this whole thing and you have to add it, yeah. Now 2 over 1/2 plus 1 is going to give us plus 4 over 3x to the power of 3 over 2. Alright, 3 divided by minus a half, okay, plus 1 is going to give us plus 6, okay, and minus a half plus 1 is just a half, okay, plus 6. That's the integral of this in the simplest form, okay. You can use your calculator, okay, for doing this. 1 over 3 divided by 3 over 2 plus 1. It is much quicker and it saves time, okay. And also the new power, basically it's going to be the old power plus 1. Just write the old power plus 1 and just divide it to speed up the process, okay. All right, here's bit tricky question over here. Not a bit tricky, but anyway, so this is a part of curve. 4 cos of x, p and q lie on the curve. Find the point of q. So basically this 4 is outside the bracket. It's a stretch on y-axis by 4 factor times by 4. Everything on y-axis is times by 4. So this is going to be 4. Okay, let me just shorten it up, yeah. Oh, sorry, minus 4. This one is minus 4, okay. And if you know the cosine graph, okay, this one is going to be 90 degrees, okay, the first intersection with x-axis, the x-intercept. This one is going to be 180. The I think this is the, what is it, the maximum, yeah, not maximum, minimum, okay. And this is going to be 270 degrees. This one over here, the maximum is going to be 360. You should know this, okay. All right, now you have to state the coordinates of p. That is going to be 270 degrees, 0. State the coordinates of q. All right, so this one is going to be minus 180 degrees, and this one is going to be minus 4 because it's transformed, it's a stretch in y-axis by a factor of 4. And state the number of solutions to the equation. 4 cos of x is equal to 3. All right, this is bit tricky. This is bit tricky, okay. And let me just make this bit clearer. All right, so this is 4, this is 4 minus 4 and plus 4. State the number of solution. 4 cos of x is equal to 3. All right, so so this one is basically this is x, a line, okay, which is x is equal to 3 line. Now y is equal to 3, yeah, sorry. Okay, this is a line where y is equal to 3, okay, and we draw this horizontally like this, yeah. All right, this is basically a straight line, okay, and that is equal to this equation 4 cos of x, okay. It looks I mean confusing, but if you have studied the graphs, the horizontal line, the vertical line graph, yeah. So this is basically the horizontal line graph, which is y is equal to 3, and gradient is 0 because it's just straight, yeah. So over here y is equal to 3 line is going to be below 3, yeah, and we draw a line here. Now how many points of intersection are there? Okay, now we have to state the number of solutions. So number of solution is basically the points of intersection. So here is 1 point of intersection, second point of intersection. All right, and yeah, there's one over here, there's one over here, but it's asking for 1800 between 0. So we start from here and we have to go to 1800. That's we can't find it. That is going to take us ages. That's not realistically possible. But you know, the sine graph is just, you know, it's a continuous graph, and we can use the symmetric properties. Yeah, okay, it doesn't like change, you know. Okay, so that means that, can we take, like, if we say, like, if there are 2 points of intersection in one interval, now how many, what is the interval of the cosine graph is 360 degrees. Then we can work out by using a ratio how much is going to be when there is going to be 18,000 degrees. Yeah, that's true. Yeah, so 360 times by 50. Now 2 times by 50 to go to 18,000. Same we can apply over here. So 50 times 2 is basically going to be 100. Okay, so there are going to be 100 points of intersection. All right, so state the number of solutions to the equation. Okay, this one slightly twist over here, slightly twisted question, but again you take 5 to the minus 5 on both sides, and this is going to give 4 cos x. 1 minus 5 is just minus 4. All right, and we have to draw a graph of y is equal to minus 4, and we can draw it over here. And there are 1 point of intersection, okay, in 360, between minus 360 and to 300. So what we can do is, can we add up these two intervals? Okay, so just to, you know, like, speed up the process. Okay, so this is going to give a 360 plus 360 is 720. Okay, so there's no need of using the, what we say, the ratio or any factors. So yeah, so it's going to be 2 points of intersect. No, two, not two. Yeah, I have to be a bit careful. It's 360, but that goes beyond there. All right, yeah, I think so. Sorry for the confusion over here. This is till 360 and this is till minus 360. Okay, oops. Now what we can do, that we can find how many solutions are there between minus 360 and plus 360. You could have done like 0 to 360, but I'm doing minus 360 to 360, just, you know, to speed up the process. Okay, so there are 2 points of intersection between minus 360 and plus 360, and what you can do, them, you can add them. 360 plus 360, yeah, is going to give us 360 plus 360 is 720. And also we can add these two intervals. Okay, this is going to give us 1440, and 1440 divided by 720, so you just times by 2, and this is going to give us 2 times 2 is 4. So there are going to be 4 points of intersection, so 4 solutions. All right, so the answer is going to be 4. Oh, this one is bit tricky here as well. All right, so 4 cos of x minus 3 is equal to 1. Okay, and this is going to give us 4 cos of x plus 3 on both sides, so that is going to give us 4 cos of x. And now you have to draw a graph of y is equal to 4 right there. All right, so now what we can do, okay, we can draw an extension, okay, because there's now we can draw an extension over here, okay. So this is 360. We can go above 360 plus 90, which is 450, plus 90 we can go 540, okay, plus 90 we can go 630, plus 90 we can go 720. Yeah, 360 plus 360, another period of 720. So we can draw another graph here, another cosine graph here. Yeah, and if we draw a line over here, all right, if we draw a line here, they are going to be how many points of intersection are here, okay. So and then we can go to beyond 1080. Yeah, you can do other ways, but I'm choosing this way, okay. So 720 plus 360 is 1080. We can draw a further sketch as well. Yeah, so 720, okay, plus 90, yeah, is 810, and 810 plus 90 is 900, plus 90 is 990, okay, and plus 90, okay, so 1080. We can draw a further sketch here and a further extension to the line. Yeah, so how many points the intersection there? 1, 2, 3 and 4, okay. And how many are going to be there? So basically this point of intersection is not going to be counted again, and some people use the ratio. If you find the ratio of this and this, that's going to be inefficient, because this one is only counted twice, counted once. Yeah, you can't count this again. Yeah, and similarly for minus 1080, there is going to be 1, 2 and 3, okay. All right, so 3 plus 3 plus 1, okay, this one over here is going to give us 7 points of intersection, because this one is an extra here. Yeah, all right, so you have to think logically over here by over extending the graph. If I've used a factor here, let's say between like 360, if you have used a factor over here, I couldn't do it over here because this one is lying between here, okay, and this one should be like treated separately. Yeah, okay, because if we count this one over here, we can't count it there again. Yeah, but yeah, and ratio is going to be just going to be bit messy. Yeah, okay, all right. Yeah, to be clear, let me just be clear if you are confused that why I'm not using the ratio, okay, to find the solutions between minus 1080 and plus 1080, okay, because of this, because it's lying right on 0, okay. Okay, if it is lying like on the 0, we can't like find the ratio. Yeah, so that is going to be like bit hard, like what I mean. Yeah, it's right on 0, okay, so that's why. Yeah, you can draw a further sketch, right? I have a bit difficulty in explaining this, but you should get the general idea, because this can be counted once, we can't like count it twice. Yeah, all right. Okay, All right, so we have uh L1 passes when it's perpendicular. Okay, perpendicular, you have to highlight this, perpendicular. Yeah, find an equation for L, and this is x minus 2y plus 25 is equal to 0. Okay, all right, so now we need to find the gradient of this line. Okay, then we can find the gradient of the perpendicular line. Okay, and we have to find the equation, so we need a coordinate, and this is origin is basically the coordinate, which is 0 and 0. How we can find the gradient of L1 in order to find L2? Well, they have given this equation, and we can write this equation in form of y is equal to mx plus c, where m is going to be gradient and c is going to be a constant, and n is the gradient. From there we can extract the gradient. So x minus 2y plus 25 is equal to 0. This is going to be minus 25 x minus 2y, or just 2y over there, x plus 25. Divide both sides by 2. Okay, 2, and this is going to give us half x plus 25 over 2 is equal to y. Now we know the gradient of L1 is a half, so that means the gradient of L2 is going to be perpendicular, so that is going to be the negative reciprocal of this, which is going to be minus 2. Okay, minus 2. Yeah, all right, and now we have to find the equation for L2. Well, you can sub in into y is equal to mx plus c, or you can use this equation over here. Y is equal to y1, m is equal to m is going to m times by x minus x1 bracket. I'm going to use this one. Y minus y1 is 0 and m is minus 2. Okay, x minus x1 y, and this is going to give x1 is just 0. Sorry, this is going to be minus 2x, and minus 2 times minus 0 is just 0. So this is going to be y is equal to 2x. L1 L2 intersect at point T. Use algebra to find coordinates of P. Simple. Points of intersection, whenever there's point of intersection, we set it equals to each other. So half x plus 25 over 2. Okay, the equation of L1 in form of y is equal to mx plus c. Yeah, y should be on its own. Okay, to find the points of intersection. Over here what we can do is minus 2x minus a half x is equal to 2052. Collect like terms. This is going to be 5 over 2x, 25 over 2, and 25 over 2 divided by minus 5 over 2. Okay, or you can do 2's are going to be cancel out. Okay, if you times 2 on both sides, they are going to cancel out, and we have 5x minus 25, and x is going to be minus 5. Alright, and we have to find the y coordinate. We can substitute in any of the equation, minus 2 times minus 5, or you can substitute to minus a half times minus 5 plus 25 over 2. Alright, and this is going to give us y is equal to positive 10. So this is our points of intersection, point A, point B. Yeah. Alright, hence find the shortest distance from L1, okay, to the origin. Okay, from L1. Now we have this points of intersection over here, hence you have to use something from the back question. So we have minus 5 over 10. Okay, and here is this is the line. Okay, from L1 to the origin. Okay, so we have to use this. Okay, and this to find the shortest distance. Yeah, to the origin we have to use this point, okay, and this point, and we have to find the distance. And this is going to be a distance formula is going to be x minus x2 minus x1 squared plus y2 minus y1 whole squared. And this is going to be, just you need to sub in the points. This is minus 5 10, and this is 0 and 0. Label this x1 y1 x2 y2, okay, and x2 is 0 minus 5 squared, okay, all right, and plus y2, okay, y2 is 0 minus 10, okay. Now you have to sub this in your calculator. 0 minus 5 squared plus 0 minus 10 squared is going to give us 5 root 5, and we need this in surd form, okay. It's fully simplified surd, okay.